So we can generalize that volume, which is measured in cubes, can be made by taking any area and giving it some thickness. So volume in cubes can be found by area or squares and give those squares some thickness. So when we think of anything, any object like that, as long as we have the same area for every piece, so in this case, if we take a look at a slice of bread, every slice of bread has the same area. We can take that area and give it some thickness to find out the number of cubes that make up that volume. So when we take a look at this slice of bread, we have this area surface here represents 120 squares. If I want to find the volume of this loaf, I take those squares and I give those squares some thickness. So the volume works out to be 120 squares. And we're going to give each of those squares a thickness of 25 centimeters. And working that out, 20 times 25 gives us 3,000. And that's going to give us cubes. And again, notice that the units squared times centimeters squared times centimeters gives us centimeters cubed. So there's our volume. And we can generalize that all volumes can be found this way because we're just going to take some square and we're going to give it some thickness. And by giving it thickness, we make it into a cube. And then we'll start measuring cubes. So even more complicated objects, such as pyramids that don't have the same slice, so every slice is different, has a different area, we can still use this general idea by just approximating what area each slice has and just taking small enough slices so that the area doesn't change too much as we go from slice to slice. So we can do this by taking this slice, finding an area, multiplying it by its thickness. That gives us volume of this slice. And then we can do the same for the next slice. We can find the area of this piece, give it some thickness, and notice that if it's a little bit smaller, eventually we're going to go up in steps to the top. And we can smooth this out. We can make this more like a smooth pyramid by taking thinner and thinner slices. That would involve more calculations, more individual area times height calculations. But we can do this and we can actually approximate these volumes of more complicated objects. And in fact, when we look at volumes of really complex objects, that's what we do. We take the area and we give it a thin enough slice so that the area doesn't change going from slice to slice, and we can just take each individual area and sum them all up. Now this would be calculation intensive if we don't have some sort of pattern that we can work with. And in calculus, when we get to calculus in grade 12, this is actually what we do in calculus. We'll come up with some generalization, some pattern that allows us to figure out how the areas might be changing from slice to slice. But again, in math in general, volume is area times height. And that's a good way to think of volume.